Have you ever looked at the great monuments of the ancient world and felt a sense of wonder? A feeling that there is more to the story than we are told? We live in an age of incredible technology. We have smartphones in our pockets and rockets that can travel to the stars. Yet when we look back into the deep past, we find mysteries that our best modern minds still struggle to explain. These are not just old stories or simple myths. They are real, physical pieces of evidence. They are whispers from a forgotten world, hints of a lost chapter in the human story. They suggest that our ancestors may have known things that we have since forgotten, possessing a wisdom that defies our modern assumptions about the past. These ancient technologies are like ghosts haunting the pages of our history books. They challenge the neat, simple timeline of progress that we are often taught in school. The idea that humanity started with simple stone tools and slowly, steadily, worked its way up to our current level of sophistication. But what if that story is incomplete? What if there were peaks of brilliance long ago, high points of knowledge that were lost in the great cataclysms of history? The evidence is there, carved in stone, buried under the sea, and hidden in plain sight. It forces us to ask uncomfortable questions. How did they do it? And more importantly, what else did they know that we have not yet rediscovered? This journey is not just about old stones and rusty gears. It is about understanding the true potential of humanity. By exploring these lost wonders, we are not just looking at the past. We are looking at a different version of ourselves, a version that could move mountains, build structures to last millennia, and map the heavens with breathtaking precision. These achievements were not accidents. They were the product of immense knowledge, careful planning, and a deep understanding of the laws of nature. A level of understanding that, in some cases, we are only just beginning to catch up with today. It's a humbling thought, isn't it? So let us open our minds. Let us step away from the comforting certainties and venture into the shadows of history. We will explore the evidence together, piece by piece. We will look at colossal structures that should not exist, at materials that defy the passage of time, and at intricate machines that seem to come from another era entirely. This is a quest for lost knowledge, a search for the fingerprints of forgotten gods, or perhaps the fingerprints of a forgotten, highly advanced human civilization. The clues are all around us, waiting for those with the courage to see them for what they truly are. Signposts to a past far more advanced and mysterious than we have ever imagined. Let us begin in Egypt, under the scorching desert sun. Here stands the Great Pyramid of Giza, a man-made mountain of stone. For thousands of years, it was the tallest structure on Earth. It is built from approximately 2.3 million massive stone blocks, some weighing as much as 80 tons. Think about that for a moment. 80 tons is the weight of several large trucks combined. The official story tells us that this was a tomb for a pharaoh, built over a period of about 20 years using simple copper tools and sheer manpower. But does that explanation truly fit the evidence we see before us? The scale, the precision, and the sheer logistical challenge are almost beyond comprehension. Consider the precision of this incredible structure. The Great Pyramid is aligned to true north with an accuracy that is astonishing, even by today's standards. Modern construction projects with all our lasers and GPS technology would be proud of such alignment. The sides of its base are almost perfectly equal in length, with a difference of only a few centimeters. The stones are cut and fitted together so perfectly that you cannot even slide a piece of paper between them. How was this level of master craftsmanship achieved with simple hand tools? The questions multiply the closer you look. How did they lift those 80-ton granite blocks, found in a quarry hundreds of miles away, up to the high levels of the pyramid's inner chambers? The mainstream explanation involves immense ramps, wooden sleds, and tens of thousands of workers. But the evidence for these giant ramps is scarce, almost non-existent. Building a ramp large enough to reach the top of the pyramid would have been a construction project almost as massive as the pyramid itself. And what of the tools? Archaeologists tell us the ancient Egyptians used copper chisels. Yet copper is a relatively soft metal. It is difficult to imagine it being used to cut and shape hard granite with such flawless precision on an industrial scale. It feels like we are missing a key piece of the puzzle, a lost technique or technology that made the impossible possible. Perhaps we are not giving our ancestors enough credit. Perhaps they understood principles of leverage, acoustics, or even some form of concrete technology that we have failed to recognize. The pyramid is more than just a pile of stones. It is a marvel of engineering that encodes sophisticated mathematical and astronomical knowledge. Its proportions seem to reflect fundamental constants, like the value of pi and the golden ratio. It is a silent testament, waiting for us to ask the right questions. It doesn't just ask how they built it, but why they built it with such unbelievable precision. The answers may lie not in what we think we know, but in what we are willing to consider. Now let us travel forward in time to the mighty Roman Empire. The Romans were master builders, leaving behind structures that have stood for 2,000 years. We see their aqueducts, their harbors, and their magnificent pantheon in Rome. The secret to their incredible longevity is a remarkable material, Roman concrete. This was not the same concrete we use today. Modern concrete often begins to crumble after just 50 years, especially when exposed to harsh conditions like saltwater. But Roman structures, like the breakwaters in their ancient ports, have endured the relentless crashing of waves for 2 millennia and have actually become stronger over time. How is this possible? For a long time, the secret of Roman concrete was lost. Scientists studied it for decades, trying to understand its incredible resilience. The key, they believed, was a special volcanic ash called pozzolana, which the Romans mixed into their mortar. This volcanic material certainly played a role, creating a uniquely stable chemical bond. However, a recent discovery has unveiled another, even more surprising ingredient. Researchers noticed small, white chunks like tiny pebbles embedded throughout the concrete. These were long dismissed as signs of poor mixing or low-quality raw materials. But what if they were not a mistake at all? What if they were the secret ingredient? It turns out these white chunks, called limeclasts, are the key to the concrete's self-healing ability. The Romans, it seems, used a process called hot mixing, adding quicklime directly to the mixture. This process creates high temperatures and results in these brittle limeclasts being embedded in the final material. When a tiny crack forms in the concrete over time, water seeps in. This water reacts with the limeclasts, creating a new calcium carbonate solution that flows into the crack and hardens, effectively healing the damage before it can spread. It is a brilliant, self-repairing system designed by ancient engineers. This discovery is more than just an interesting historical fact. It is a stunning revelation. The Romans did not just invent a strong building material, they invented a smart material. They engineered a concrete that could actively repair itself, ensuring their monumental structures would stand as a testament to their power for ages to come. It shows a level of chemical and material science sophistication that we are only now beginning to replicate. It makes you wonder what other secrets are locked away in the materials of the past. What other simple, elegant solutions to complex problems have been forgotten, waiting to be rediscovered by modern science. Our next stop is not a massive monument, but a small, corroded lump of bronze recovered from an ancient shipwreck off the coast of the Greek island of Antikythera. For decades after its discovery in 1901, it sat in a museum, its true nature a complete mystery. It looked like nothing more than a rock. But as scientists began to examine it with X-rays and advanced scanning technology, they uncovered something extraordinary. Hidden inside was a complex system of interlocking bronze gears, a machine of breathtaking complexity. This device, now known as the Antikythera mechanism, has been called the world's first analog computer. Dating back to the 2nd century BCE, this device is unlike anything else found from the ancient world. It is a clockwork model of the cosmos. By turning a handle, a user could track the positions of the sun, the moon, and the 5 planets that were known at the time. It could predict solar and lunar eclipses with startling accuracy. It even had a dial to keep track of the 4-year cycle of the ancient Olympic Games. The complexity of its gear trains, some of which use differential gears, was not seen again in technology for over 1,000 years. It is a piece of technology that simply should not exist in the ancient world, according to our standard historical timeline. The existence of the Antikythera mechanism forces us to completely reevaluate what the ancient Greeks knew. We think of them as great philosophers and mathematicians, but this device shows they were also master engineers and astronomers. They had the ability to translate their complex astronomical theories into a physical, mechanical reality. Who designed this? Who had the technical skill to craft such tiny, precise gears from bronze? And was this a one-of-a-kind marvel? Or was it just one example of a common tool for astronomers of the time, the only one lucky enough to survive? The shipwreck that preserved it also hints at a tragic loss of so much more. This single object rewrites a chapter of human history. It tells us that the roots of complex mechanical engineering are far deeper than we thought. It suggests a lost tradition of scientific instrument making that flourished 2,000 years ago and then vanished. Why did this knowledge disappear? The mechanism is a ghost from a lost world, a tangible piece of evidence that our ancestors were observing and calculating the movements of the heavens with a sophistication we are only now beginning to appreciate. It stands as a silent challenge to our assumptions, a beautiful, complex puzzle box from the depths of the sea. Not all lost technology is made of stone or metal. Some of the greatest losses are found in the ashes of knowledge itself. The most famous example of this is the Great Library of Alexandria in Egypt. This was not just a library as we think of it today. It was the intellectual center of the ancient world. Founded around the 3rd century BCE, it was a place of research, learning, and discovery. It aimed to collect all the world's knowledge under one roof. Scholars from across the known world came to study and to add their own works to its vast collection of scrolls. It was a shining beacon of human intellect and curiosity. Imagine for a moment hundreds of thousands of scrolls containing works of mathematics, astronomy, engineering, philosophy, and history. Here, Eratosthenes calculated the circumference of the Earth with incredible accuracy. Here, Hero of Alexandria experimented with steam power, creating the world's first steam engine, the Aeolipile. Here, the foundations of geometry and medicine were laid down. The knowledge contained within the library's walls was the accumulated wisdom of generations. It was really the hard drive of the ancient world, a priceless repository of information that was pushing humanity forward into a new age of understanding. It was a treasure more valuable than any gold or jewels. The destruction of the library was not a single event but a slow, painful decline over several centuries. It suffered from fires, budget cuts, purges, and religious conflicts. The final definitive loss is a subject of historical debate, but the result is the same. An incalculable amount of knowledge was lost forever. Scrolls describing forgotten histories, lost scientific principles, and advanced engineering techniques likely turned to ash. What if the Antikythera mechanism was fully described in a scroll that was burned? What if detailed blueprints for pyramid construction or the formula for self-healing concrete were lost in the flames? We can only speculate about the wonders that vanished. The loss of the Library of Alexandria represents one of the greatest tragedies in human history. It was, truly, a bonfire of knowledge that set humanity back by centuries. Imagine where we might be today if that knowledge had survived and continued to grow. Perhaps the Industrial Revolution would have happened 1,000 years earlier. Perhaps we would have understood our place in the cosmos much sooner. The empty shelves of the library serve as a powerful and heartbreaking reminder of how fragile knowledge can be. It shows that progress is not guaranteed, and that the wisdom of the past can be wiped away by the ignorance and violence of the present. It is a deeply unsettling question. How could such incredible knowledge be lost? How could humanity forget how to build like the Romans or calculate the heavens like the Greeks? The answer is not simple. It is a combination of many factors, a perfect storm of history that erased entire chapters of our story. One of the primary reasons is the collapse of civilizations. When the Western Roman Empire fell in the 5th century CE, it was not just a political event. It was a systemic breakdown of society. The complex trade networks, stable governments, and educational systems that supported advanced engineering projects all crumbled. In the chaos that followed, survival became the top priority. There was no time, money, or stability to maintain large-scale aqueducts or train new generations of master engineers. Specialized knowledge, which was often held by a small number of experts, could easily be lost in a single generation. If the masters died in a war or a plague without passing on their secrets, that knowledge died with them. Many of these advanced techniques were likely trade secrets, not written down in public manuals. They were passed from master to apprentice through years of hands-on training. When that chain was broken, the knowledge vanished into thin air. Natural disasters and deliberate destruction also played a huge role. We have already spoken of the catastrophic loss of the Library of Alexandria, but this was not an isolated incident. Throughout history, conquering armies have often destroyed the cultural and scientific records of the people they defeated. It was a way to erase their identity and impose a new order. Temples were torn down, books were burned, and scholars were killed. In this way, knowledge became a casualty of war and ideology. What we have left is a fractured, incomplete record, like a book with most of its pages ripped out. We are left to guess what was written on those missing pages. Furthermore, we must consider the materials themselves. Much of the ancient world's knowledge was recorded on perishable materials like papyrus scrolls or parchment. Unlike stone or metal, these organic materials decay easily over time unless they are preserved in extremely dry conditions, like the deserts of Egypt. For every scroll that survived, thousands, perhaps hundreds of thousands, have rotted away to dust. The knowledge we have is the knowledge that was lucky enough to survive. It is a story of accidental survival against overwhelming odds. This makes the few artifacts we do have, like the Antikythera mechanism, even more precious and miraculous. The study of these lost ancient technologies is not just an academic exercise in looking at the past. It has real and powerful implications for our present and our future. When scientists rediscovered the secret to Roman concrete's self-healing properties, it was not just a historical curiosity. It sparked a wave of innovation in modern materials science. Researchers today are actively working to create new types of self-healing concrete inspired by the Roman formula. Imagine buildings, bridges, and infrastructure that can repair their own cracks. This ancient wisdom could help us build more sustainable, durable, and less wasteful cities for the future. The Antikythera mechanism also has echoes in our modern world. It reminds us that the drive to compute, to model our world, and to predict the future is not a new phenomenon. It shows that the fundamental principles behind our modern computers, using a mechanical system to process information, have roots stretching back more than 2 millennia. It challenges our hubris and forces us to recognize the genius of our ancestors. It inspires us to think differently about the history of technology and to look for clues in unexpected places. The mechanism is a testament to human ingenuity, a quality that connects us directly to those ancient Greek engineers. Even the mysteries of the pyramids can teach us valuable lessons. While we may not know exactly how they were built, studying their design and alignment reveals a deep understanding of mathematics, engineering, and astronomy. The questions they pose push the boundaries of modern archaeology and engineering. They force us to develop new analytical tools and new ways of thinking to solve these ancient puzzles. Research into acoustic levitation or advanced stone-cutting techniques, while speculative, opens up new avenues of scientific inquiry. The pyramids are not just tombs, they are catalysts for curiosity and innovation, urging us to keep searching for answers. In a way, by studying these lost wonders, we are engaging in a dialogue with the past. We are learning from forgotten masters. The lesson here is one of humility. It teaches us that we do not have all the answers and that progress is not always a straight line forward. Sometimes, the best way to move forward is to look back, to rediscover the elegant and sustainable solutions that our ancestors devised. Their knowledge, born from a different way of seeing the world, can offer us fresh perspectives on the challenges we face today, from sustainable construction to our relationship with the natural world and the cosmos. The most exciting part of this entire story is that it is not over, not by a long shot. We are living in a golden age of discovery. New technologies are allowing us to peel back the layers of history in ways that were previously unimaginable. Satellite imagery can now detect the outlines of buried ancient cities hidden beneath desert sands or jungle canopies. Ground-penetrating radar can map out underground structures without ever digging a single hole. We can see the ghostly shapes of lost buildings, roads, and even entire settlements, guiding archaeologists to places no one has looked before. The Earth is giving up its secrets. Consider the oceans, the world's largest museum. It is estimated that there are over 3 million shipwrecks lying on the ocean floor, most of them unexplored. The wreck that gave us the Antikythera mechanism was just one of them. What other technological marvels lie waiting in the deep, preserved in the cold, dark waters? Advanced robotics and deep-sea submersibles are now making these sites more accessible than ever. Every new wreck discovered is a time capsule, a snapshot of a lost world, potentially holding another impossible artifact that could once again rewrite our history books. The next great discovery might be just a shipwreck away. New scientific techniques are also allowing us to analyze old discoveries in revolutionary new ways. We can now analyze the DNA from ancient bones, trace the chemical composition of pottery to its exact source, and use particle accelerators to read the text inside burned, unreadable scrolls. The lump of bronze that became the Antikythera mechanism was studied for decades before X-ray computed tomography revealed its inner secrets. How many other artifacts are sitting in museum basements, mislabeled or misunderstood, just waiting for the right technology to unlock their true meaning? We are rediscovering the past that was already in our possession. This ongoing process of discovery should fill us with a sense of profound optimism and excitement. We have not found all the pieces of the puzzle, far from it. There are still vast areas of our planet that remain archaeologically unexplored. There are secrets buried beneath the ice of Antarctica, hidden in the dense Amazon rainforest, and submerged off our coastlines. The story of our past is still being written, and we are the ones who get to uncover the next chapter. The whispers from our ancestors are growing louder, and with our new tools, we are finally learning how to listen to them more clearly than ever before. So, where does this journey into the lost world of ancient technology leave us? It leaves us, I believe, in a place of profound wonder and humility. It forces us to discard the old, arrogant idea that we are the pinnacle of human achievement, and to embrace a much more mysterious and interesting version of our own story. Our ancestors were not primitive people waiting for us to invent the future. They were brilliant innovators, scientists, and engineers in their own right. They built wonders that still defy our understanding and created technologies whose elegance we are only just beginning to appreciate. This exploration teaches us that we are a species with amnesia. We have forgotten a huge part of our own heritage, but the clues to recovering that memory are all around us, in the silent stones of Giza, in the self-healing concrete of Rome, and in the intricate gears from a Greek shipwreck. These are not just artifacts, they are messages from our past. They are a challenge to our intellect and an invitation to our curiosity. They ask us to be more open-minded, to question the accepted narratives, and to have the courage to admit when we simply do not know the answer. That admission is the first step toward true discovery. The future of understanding our past is incredibly bright. As our own technology advances, we will unlock more and more of these ancient secrets. We will find new sites, re-examine old ones, and piece together a more complete picture of who we were and what we were capable of. Perhaps one day we will find an intact scroll from Alexandria that explains a lost mathematical principle. Perhaps we will find another, more complex mechanical computer in the depths of the Mediterranean. The possibilities are endless, and that is what makes this quest so compelling. The greatest discoveries may still lie ahead of us. Ultimately, this is a story of hope. It is the story of human resilience, ingenuity, and the unquenchable thirst for knowledge. By unveiling the lost wonders of the ancient world, we are not just learning about them, we are learning about ourselves. We are connecting with a legacy of genius that stretches back into the mists of time. It reminds us that there is more to this world than we can see, and that the human spirit has always been capable of achieving the seemingly impossible. The past is not dead, it is waiting for us, and it has so much more to teach us. Let's keep searching. If you enjoyed this journey and want to uncover more lost wonders with us, make sure to subscribe and turn on notifications for upcoming videos and updates. Your support helps us keep exploring the mysteries of our past, together.